So, hi all. My name is Shane Murphy. I am Technical and Sales Director at Ashgrove. I will be talking through the various home energy upgrades. We'll be talking about a little bit about vacant house and derelict house grants, and obviously a little bit about SAI and the various grant types, the various criteria, I suppose, eligibility criteria, first of all, to be allowed into the scheme, and then the minimum criteria that we have to hit by the end of the scheme, or various schemes, I should say. So we'll hop along. Okay. So we'll be covering a brief introduction. We'll be talking a little bit about Ashgrove's experience, so a little bit, not too exciting, but some news to you. We'll be talking about the various grants and criteria, as I said. We talk about the administration and the process of the various grants and who does what and why, when, etc. And we talk about a little bit of the technical side of the various upgrades. Some of them we won't, there isn't enough time to cover in a short presentation like this. But we'll probably end up covering a little bit about the solar, because it's the one that most people seem to have questions about. We'll talk about maybe 2 case studies, and we'll talk about the various funding options that are becoming available, etc. So we know that SEI is, under huge pressure to roll out these upgrades across the country. The major focus, certainly, of our talk today is on housing. We know that by 2030 that there is a focus to get 300,000 homes upgraded, and we know that they've significantly increased the grants since actually this time last year, and as well as that, they have brought out these new grants, which are the derelict house grant and the vacant house grant. So we'll be talking a little bit about those, and a tiny little bit about Ashgrove. We're around since 2001. We've been working with Sustainable Energy Authority of Ireland since 2006. We've about 16,000 systems in operation around Ireland and the UK. So last year there were 1,400 projects, and in many people's eyes, they're systems that need to be installed, but what they don't see is the work that happens that isn't on site. So the design work, the communication, the scheduling, the quality control side of it, all the checklists, the signing off of it, the certification, the handover, the training, the after sales. So the installation is probably, from our side, is roughly about half of the time that goes into any project. So that's worth noting, to get it fully, I suppose, and successfully operating in such a way that the customer is happy with it. Sometimes we see people just installing these systems and maybe typically heat pumps or something like that, ventilation systems, where very little care is taken at design stage and zero care is taken maybe at commissioning and handover stage. And we hear then what we would expect to hear: the system never performed, the running costs were too high, etc. So there's no real surprise in that. When we hear that, people, half the country probably doesn't take a huge amount of care at it. So we probably won't get an awful lot of time to go into it in this presentation, but there's a lot of time that goes in. Okay, so wrong button. So question that we're asked all the time in these talks is about the paperwork. In a lot of the cases, the derelict house and the vacant house grants, the homeowner has to do the paperwork. In the BEC, Better Energy Communities are the one-stop shop. The installer or the contractor, i.e. Ash Grove or a similar contractor. We do the paperwork. There are some grants like solar panels. So if you were just doing solar panels only through what is known as an individual measure grant. So a person who just wanted to do one measure, it being solar or attic insulation or wall insulation, well, they would in that case do the paperwork themselves. Now, in reality, we walk them through it. We have videos to assist them in filling out the forms, and sometimes we might even do a Zoom meeting or a Teams meeting or something like that to assist them in doing it. But the money in that case goes into the customer's account, and so therefore their account details and so on need to be uploaded with that application. In the other case, the grant comes to the contractor retrospectively. So in that case, the customer would go off and get the works done. The customer only has to pay for the net amount, and so therefore it's the SAI contractor then has to go off and claim the grants, and it's their problem to wait until grants arrive. It's typically quite quick, by the way, typically kind of 6 weeks or something like that. We talk through it anyway as we go. So questions, if you have any questions as we go, you'll see at the bottom of your screen a little Q&A, little speech bubble icon. If you want to click on that, type in any question that you have and throw that across. I'll keep an eye on it. I have a colleague who's also here who is answering them by text if I can't answer them as I'm speaking. So we'll try and get to cover all the various questions. I'll cover them as I come across them, if that makes sense. In some cases, I'll just cover them at the end. If it's not, if question isn't pertaining to a particular part that I'm covering, I'll leave it until either it's relevant or I'll leave it until the end. So, benefits of home energy upgrades, obvious enough, I guess. Reduced energy costs, reduced energy spends, a warmer, healthier home, environmentally friendly, of course. We obviously want to reduce our carbon footprint. In most of these cases, you have to achieve a BER of B2 or better. It increases, of course, the value of your home. Obviously, it's like miles per gallon in your car. Obviously, the more efficient it is, the more valuable it is if somebody else wanted to buy it. Nobody wants to buy a car that will do 5 miles to the gallon. So equally, nobody wants an F or a G house. Everybody wants a B or an A, and they're willing to pay more for it. And the statistics show that if you were living outside of Dublin, to go from a D2 to a B2 will increase your house by 12%, will increase the value of your house by 12%. If you're inside of Dublin, a D2 to a B2 will increase the value of your house by 16%, right? So that is quite significant. So obviously keep it in mind if you're either buying or selling. So benefit of, or another benefit is typically improved air quality when you upgrade your house. Now, sometimes if it's badly done, you can have the opposite effect. I spoke with somebody in the last few days who had actually insulated their house a few years back, and it's obvious enough now. They realized they made a mistake, but when they insulated it, they did a good job, but they reduced the amount of fresh air getting into the building, and to the point where they feel unhealthy. And now they know that if they stay someplace else while they're on holidays for a week, they feel better than they do in their own house. So they can see mold in the corner of the rooms, etc. So air quality should be a result of an upgrade, but it doesn't always transpire that way. So green mortgages. A green mortgage, we see a lot of people, I suppose, in a hurry to get their house into a green mortgage. It can be up to 0.9% lower than your typical mortgage interest rate. Now, 0.9, I'd have to say, is on the strong end of it there. I would guess that what we typically see is 0.5, 0.6. We've seen it as low as 0.3 better. But typically, 0.3, 0.5, let's call it, percent lower is, over a 20-year mortgage or a 25-year mortgage is still a significant amount of money. And then you have a low interest rate green loan also available. So some of the banks already are after introducing this themselves. In some of the cases, they haven't, but the government are also introducing their own version of this, which will be administered, we understand, through the banks. The main banks. We're still waiting for more details on this. So a tiny little bit about Ashgrove. I'm not going to bore you with this, but these are maybe just some past projects gone back over the last 10 years, even though this one is 15 years. Bottom right here is a large house that we've done in Ireland, 55,000 square foot house. The top right hand one here is a similarly huge house on the island of Jersey off the north coast of France. These are big, very high-end houses with, in these cases, they were all geothermal or ground source heat pumps doing heating and cooling, indoor and outdoor pools in both of those cases, actually. The other case is a house in London. We've also, gone back 5 or 6 years, done large apartment blocks in likes of this is Reading, just outside of London. We did the full mechanical contract here, which is air-to-air heat pumps, includes plumbing, heating, combined heat and power. That's essentially a little gas engine. Nothing little about it. It's a gas engine which produces electricity, and as a byproduct, you get heat. These are significant projects. The next ones here are large heat pumps. So where a domestic house might be kind of 5, 6 kilowatt to 10 or 14 or 16 kilowatt, you can see here these projects are up to 2,000. So these are large systems. These are typically in the UK, and it was into kind of food factories or large, extremely large businesses where they either needed heating or they needed cooling, or maybe they needed simultaneous heating and cooling. Anyway, so none of these we're going to be talking about this evening. The only reason we put them up on the screen here is to essentially, I suppose, display, number one, I suppose, that we're a technically competent company. We have a team of project managers. We have a team of QA and quality people who make sure that risk is eliminated as much as at all possible from any project. And that's as important on a small domestic scale project as is on these huge commercial industrial installations. And in fact, possibly more so, for the simple reason that I suppose over 90% of the projects we do are domestic, and it's it's like a pilot being the start of every flight goes through a checklist. It's mistake elimination. It's not to say that he doesn't know what he's doing. It just reduces errors. And all of these projects, I suppose, up here are to demonstrate that we're a professional outfit. Hopefully, every now and then, of course, we have issues and we deal with them, as you'd expect from a 20-something-year-old company, delivering projects like this around Ireland and the UK. So, okay, so why are we here? I suppose we're seeing a lot of interest from people who are, they know that the grants are available. They know that there are, in theory, insulation grants, heat pump grants, solar grants, windows and doors, and maybe other things, but they don't really know quite where to start. And so they end up talking to SEAI or maybe a BER assessor. In some of the cases, the BER assessors aren't up to speed on the latest grants. Or they might be doing one particular type of work predominantly, and therefore maybe don't know an awful lot about the other type of grant. So there's a bit of going on. So I suppose the whole idea of SEAI having, I suppose, registered contractors like Ashgrove, as whether it's a one-stop shop or a BEC provider or a BEH provider, we're supposed to be kind of your interface. So you're facing a representative from Ashgrove, and I suppose you're safe in the knowledge that we are coordinating the other trades behind us. So if you need us to do we'll say if it's a one-stop shop or a BEC type project, we will organise the BER. We're not allowed to do it. It has to be an independent third party. We can organise it on your behalf, and we can organise then insulation contractors or heat pump contractors, windows, doors, and solar, etc. So you effectively have to deal with your bank, which is something most people are used to dealing with, and then you're dealing with one face or one company at least in Ashgrove, or indeed one of our competitors. Either way, so that's what we're here for. So what we're going to cover today is we're not going to go into too much detail on this particular part of it here, other than to say that the whole idea of the various grants is to get your house from wherever it's starting off, whether it's a G or a D or an E or whatever it is, to get it as high up that ladder as we can without spending a pile of your money, obviously. So we won't be spending a lot of time at this side of it, but a house's energy consumption, where a car, as we said a while ago, might be miles per gallon. A house is kilowatt hours per square meter per year. So, you know, obviously the bigger the house, the more energy it will consume. And so the worse the insulation is, or the more drafty it is, the more energy it will consume, etc. So again, we won't be going into it much other than just, I suppose, keep these figures in mind. A G is 450 kilowatt hours or worse. When we get up to an A1 or an A2, an A1 is below 25 kilowatt hours, an A2 is 25 to 50, etc. This will become important later on. You don't need to know it, but it's a box we need to tick in order to get grants. People forget this. We need to take a poor house and make it good. SEI, along with the taxpayer, have no interest in taking a good house and making it brilliant, or taking a really bad house and making it poor. They want to make a poor or bad house and make it good or excellent. So, and how we demonstrate that significant jump is in kilowatt hours. So, and the number of kilowatt hours that we need to demonstrate is 100. So if we're at, say, a C3 here and we're at 200 kilowatt hours, we need to improve the house by at least 100, which brings us to a B2 or higher. But that's the number we're going to be hearing about later on. Okay, I'm going to keep moving. So, what are the best upgrades? We're asked this quite often, and we always measure it according to three things. The first one is how effective a measure is, how disruptive it is, and how expensive it is. We can have something like attic insulation, which is not expensive and it's not disruptive and it is very effective, so that should always be done, as opposed to maybe changing maybe doors, which can be maybe not massively effective. In some cases it can be, but doors are quite disruptive because there's obviously plastering and all of that involved typically. Windows, you know, if you're doing all the windows, that can be enormously disruptive. External wall insulation or dry lining is probably the most disruptive, where you're adding insulation on the inside of every wall, of every outside wall at least. And so the skirting board has to move, the window boards have to be moved, the curtain poles have to come down, light switches, anything that's on that outside wall has to move. So we are always trying to juggle those three things. So SAI estimate that up to 30% of energy from a house kind of 15 or 20 years ago was lost through the roof, up to 35% lost through the walls, up to 10% lost through the windows and doors, up to 10% through the floor, and up to 30% through ventilation losses. We'll be talking about them more as we go through the presentation. So I'm going to rifle through what you can do for your house here fairly quickly to give you a quick overview of the various grants. So the first thing often is solar. Start at the roof of the house. You can generate electricity and you can get grants of up to €2,400. Talk about it a little bit after, but it produces direct current, which we convert to alternating current. Okay, roof insulation. This is where we will be insulating over your head if you were standing in the attic. And you can see here there are three different figures: 2,000, 3,000, and 3,000. So a detached house is always the biggest figure, mid-terrace being the smallest. So in this case, for the ceiling insulation, is €1,500 for a detached insulation, detached ceiling insulation. Sorry, a detached house with ceiling insulation. Mechanical ventilation you cannot get as an individual measure. You could get the other two we just saw. Windows you cannot get as an individual measure. You have to get it as part of an overall home improvement package. Doors, you're about to see here, you can get 800 per external door, not internal doors. And again, has to be part of an overall house improvement package. Heating system, the same. You can get up to €2,000 if you're improving your radiators or increasing them in size such that they are suitable for working with the heat pump. Floor insulation, this would be always as part of a multiple measure upgrade. So again, you're really gutting the house when you're doing floor insulation. But if you are, you're going to get 3,500 for the floor insulation. The heat pump grant here, the air source, there are two grants. If you're just doing the heat pump, you'll get 6,500. Whereas if you're doing a one-stop shop or a BEC, you will get 8,500 because you're getting bonus payments. External wrap, for a detached house, it's up to €8,000. It's costing, unfortunately, somewhere around 150 or 170 euros a square meter. Cavity wall insulation is not disruptive, and this is always good value, and you should always definitely do it if it's available. And for a detached house, you get €1,700. And dry lining, you will get up to €4,500 for a detached house. So typically covers somewhere in or around maybe half of the cost. So air tightness is probably the only grant, it's one of two grants we don't know at the start whether we will get or not. The other one is the ventilation. It's a very difficult grant to get over the line. We'll talk about that again. So there are 5 types of grants. One of them is a fully funded energy upgrade. This would be for anybody getting a fuel allowance. So there are 7 different criteria where you would get a fuel allowance. I won't go through them. Ashgrove don't actually do this grant. We're not on the framework for it. We probably will be in the future, but at the moment we just we're already under pressure with other types of frameworks. What I would say is that there is a massive wait list at the moment for these projects. Is typically kind of 3 years is what we're hearing. So while it is fully funded, you will be waiting for 3 years for it. So most people come back to us and they say they'll either go into an individual energy upgrade grant, or in 95% of cases they go into either a one-stop shop or a BEC. A BEC is something that you wouldn't have heard a lot about because it's not available directly to the public. You have to come through a company like Ashgrove, or again one of our competitors, and we take houses, we bundle them together with something like a community centre or a church or a school or something like that, and we create an energy community project. So a BEC, Better Energy Communities, but a customer can't get access to that directly, so you won't see an awful lot about it online. Fourthly, the vacant house grant, we'll be speaking about that straight after this slide. We'll talk a little bit. 5, the derelict house grant. So we jump straight onto those. I'm not going to spend a lot of time on it because after starting off before I should have. So the vacant house grant is for any house that hasn't been lived in for 2 years or more. This is always evidenced by the electricity bills. So either the electricity was disconnected 2 years ago or more, or you can demonstrate that the electrical connection was there, but the energy consumption was 0. And so you, at the moment, you have to prove ownership or evidence that you're in negotiations to buy the property. Ultimately, you won't be able to get the grant, obviously, unless you definitely own it at that point. So you have to live in the property as your principal private residence. They're about to change that so that it will include landlords who want to renovate properties like this. Obviously, it's in everybody's interest that there are more houses available. The original intent was that they wanted to keep the guys with the deep pockets away from wanting to buy, the housing stock, and keeping the poor guy trying to get on the property ladder off of it. So lastly, there, have proof. You have to have proof that the property was vacant for at least the last 2 years, as discussed, and that it was built before 1993. There are different ways of providing evidence for that. So the derelict house grant is €20,000. On top of that, you will need a quotation for the various works that you're doing. That's a relatively straightforward piece of work to do. You'll need an independent report confirming that the property is structurally unsound or dangerous. Now, that's broken windows, slates or tiles falling off or something like that. Once you have that done, you send it off to, you get the form on gov.ie, and you essentially, if the house isn't on the derelict house register, you will get it signed off that it is, and at that point you can go off and you can do your works. So that's it. Now, you can get those. So between the vacant house and the derelict house, you can claim up to 50,000 if, as I say, the house is derelict or not occupied for more than 2 years, and if there's windows broken, or if there's structural damage or whatever it is. You can get to SEI grants in parallel, so you can get in theory 50,000 for the vacant and derelict house grant, and you could at the same time get 25 or 30 or 35 in the SAI grants, but it can't be for the same thing. So obviously the SAI grants are only, as you'll see in a second, only for insulation and energy side of it, whereas the derelict house, then if you were spending the 50,000, well, that needs to be on the roof, not the insulation. It needs to be on external plastering, it needs to be on structural work, it needs to be on wiring, something like that, but it cannot be on the energy related stuff. So that's it. So just keep in mind, throw in any questions there to the Q&A. I'm covering the various things as they're popping up. So an individual energy upgrade, who is this for? Well, it's for anybody who wants to do something like solar panels, or as I say, attic insulation, wall insulation, but I want to do it as an individual piece of work, because there are various reasons. I might want to either manage it myself, or I want to do a piece of work this year and I'll do another piece of work next year and I'll do another piece of work the following year, just from a cash flow point of view. So that might suit certain people. In this case, you will apply for the grant yourself, but you must pay for the full cost of the works. When it's all finished, you will go off and you claim the grants from SEAI. Criteria: the houses have to be built before 2011 if you want to get insulation or heating control grants. But if you want to get a heat pump or solar, once the house is built before 2021, you can claim those. Well, the reason for that is very simple. If you built a house in 2019 and didn't insulate it properly, the view would be that it was your own fault and the taxpayer isn't going to assist you in upgrading your house. Whereas you could have legitimately built a house in 2019 where you still hit all the building regulations, but you didn't use a heat pump or solar panels. Nearly impossible to do, I'd have to say, but it is possible that you could have done it. So that's why there are two different dates there. I'll rifle down through the grants here, so you can see in this case your house will get €6,500 of a grant for a heat pump. I won't talk about apartments today. Air to air, again, we won't talk about either. Heating controls, there's a €700 grant for heating controls, but that's already included in your heat pump. So you're not going to get 6,500 for the heat pump and 700 on top of that. The heat pump is deemed to have intelligent controls already. So solar hot water, we really don't see it anymore. So attic insulation, as we went through the various things, I'm going to skip down through the figures. You can see this on the SAI website. All I will say is that What you will not see on here, windows and doors, you will not see floor insulation, you will not see bonus payments, you won't see project management grants, the same as you would see in the one-stop shop or in a BEC. Another thing is that you have 6 months in which to complete a project like this. So if you apply for one of these grants tomorrow, you have 6 months in which to carry out the works, after which point you'll have lost your grant. So that's it. So I'm going to jump on now to the multiple measure, which is what we probably see being 90% of the projects. So a one-stop shop, you'll have probably heard a lot about this in the media. Who's it for? It's for a homeowner or a landlord. Actually, I didn't say that in the last slide. The landlord actually can get grants as well for any individual measure, same as this. So it's for homeowners or landlords who want to do multiple upgrades. So attic insulation, pump the walls, maybe change the windows and doors, put in a heat pump and maybe solar or something like this. So the benefit, sorry, I'll go through it and I'll talk about the benefits after. To upgrade a project under this scheme, you have to reach a minimum of a B2 when you're finished, not when you're started or anything else, but it has to be certainly a B2 when you're finished. Now, it can't be very nearly a B2, but it is a B3 or anything like that. It's a very simple calculation, and it's either a B2 or it's not. In this case, whether it's a one-stop shop or a BEC, it'll be fully managed by a contractor like us or any equivalent. And last, especially in the case of the one-stop shop here, the company pays for the works and then goes off to get the grants. The customer pays for the net amount. So I'm going to give you an example. For example, somebody wants to do, somebody has a 25-year-old house, they want to do the attic insulation, pump the cavities, get solar panels installed and a heat pump, and it's going to say, I'm going to say it's 30,000 euro to do it. The grants are 20,000 euro for argument's sake, and the net cost to the customer is 10. So what would happen at the start of that project is the customer would give us 50% of a deposit, which would be 5,000 out of the 10. When we're finished the project, the customer would give us the other 5,000. So they've paid us 10,000 at that point, and we then go off with our paperwork to SEAI to claim the remaining 20 in grants. And that grant lands into our bank account where it stays. So you take the point. The customer pays for the net amount, and because the government do not want the end user having to find the 30,000 to start with, they only find the 10, and therefore the grant goes to the energy company. So in this case, the dates are slightly different. It's 2011 in both cases for insulation and heat pumps. And again, as said above, the house has to reach a B2. So what's interesting, I suppose, when we look at the grant amounts here is that you have extra bonus payments. So I've circled them in green here. You get an additional 2,000 euro for your heating system, which you cannot get as an individual measure. So that's 2,000. You get a launch bonus as well for the heat pump, another 2,000. You can get floor insulation if you're doing it. It's 3,500 euro. You can get windows. If it's a detached house, it's 4,000 euro. Two doors, as we said earlier on, you can get 800 euro each for external doors. Mechanical ventilation, 1,500 euro. Air tightness up to 1,000. You can get 350 for an energy assessment, where it's 50 euro under the individual measure grant. Project management then for a detached house is 2,000 euro. All in all, there are a significant amount of extra payments under the one-stop shop in the BEC. I'll show you in a second why. But quite often when people come to us looking for maybe solar panels or heat pumps or something like that, we try to tell them, maybe it's worth looking at your attic insulation or wall insulation. And the reason is it tips you into a far better grant, which makes things much cheaper for you. And in a lot of cases, makes the decision for the customer much easier to go ahead and do all of the work in one go, rather than dragging it out over 3 or 4 or 5 or 10 years or whatever it is. So here is such a project as an example. This is a project was done the year before last now, and it was done as a one-stop shop type project, even though it was run through. Yeah, let's leave it at that. So it was a semi-detached house. You can see the pictures there on the bottom. The year of construction was 2003. The house was 103 square meters, 2-story. Free works, BER was a C2. Now, when these people came to us, they were looking for solar panels. Solar panels at the time would have been around €7,000 after the grant. We knew that when the house was starting off at a C2, that we could pump the cavities. We could easily do the attics because they were very small. And that if we put it through a BEC, the works, because I was unlocking these bonus payments, the works were going to be very cheap. So here's what we did. We did attic and cavity wall insulation, air to water heat pump, solar panels. We got about 70% of a grant, but that was I should take that out. It's not that the grant is 70%, it's just that the grant turns out to be roughly 70% in this case, right? So that's a little bit misleading. But in this case, the cost of all that works after the grants was €8,100. So from the customer's point of view, they were about to spend €7,000 to get just the solar done. The heat pump, incidentally, would have been something around the same if they just got it and got the grant. But by getting it all done, they got the project management, they got the €2,000 to upgrade the radiators, they got the launch bonus for the heat pumps, and so on and so on. So you can see there the benefit of going through one-stop shop or BEC. You get a lot more grants available to you. So the house got to an A3 for €8,000, which is a great result, and obviously the customers are delighted with that. So now to go back and explain, so in this case, as a one-stop shop, what would happen here is that Ashgrove would come in on a Monday, for argument's sake, and do pump the walls with bead. At the same time as that's happening, the attic is being insulated. By the following evening, we can have the solar panels installed on the roof and the cable ran down to the fuse board. And by the following day, then we have plumbers there fitting the heat pump, etc. So by the time the heat pump is finished and all of that is done, maybe by, I'm going to say Thursday, and then an electrician arrives on Friday, everything is wired. In 1 week, it's all done. So if Ashgrove were bankrolling this, they're not bankrolling it for long, they're bankrolling it for a few weeks. So they're starting spending money on Monday. By Friday, the project is finished. The customer is paying them as per our example a while ago, the customer is paying them the €10,000, or in this case, €8,000. And Ashgrove go off then to get their €20,000 of grants from the government. But we don't mind running that as a kind of one-stop shop type project because it's a short time span. The next project is a situation where it really is not suited to a one-stop shop. And this is why the one-stop shop is after getting maybe a little bit of bad press over the last 12 months. And this is maybe a good example of why. So, similar size project. In this case, it's in square feet for some reason. 105,050 square feet, so in around the same size. This is a house in the country, a detached bungalow, and they're gutting it. So they're taking out the floors, they're building an extension onto it, and they're looking for guidance on the grants. Now, when these people contacted us, they knew or they had heard that they were entitled to get €6,500 for the heat pump, but they weren't aware of anything else. So I'm just going to zoom in if I can. Don't mess it up. So in this case, the customer, as it turns out, because the house was old enough, it was poor enough starting off, it was going to be above a B2, and by the time they finished, it hit all the various criteria. So they're going to get the 6,500. They're going to get the 2,000 to upgrade the heating system. They're going to get the launch bonus 2,000. They're going to insulate the attic. They're going to get 1,500. They're going to do the floor 3,500. By the way, they were doing all of this anyway. So 3,500 for the floor insulation. The solar was the only thing in this case that the customer was debating, but definitely they were doing it by the time they saw the grants. So, and that's per kilowatt there. So that ends up being 2,400 in total. In this case, they were going external wrap on the original house, so they were getting 8,000 for it. They were going to get the windows. They were going to get 4,000 euro for that. They were going to get 1,600 for their 2 doors. They were going to do the mechanical ventilation, the air tightness. They were going to get 350 for their home energy assessment. They were going to get 2,000 for project management. So that amounted to 36,350 plus energy credits. Now, in that case, the energy credits would probably be somewhere around 1,000 euro. And so this customer came in thinking they were getting 6,500, and they left getting 37,350, roughly speaking, depending on how much the energy credits go for. So we don't know that at any point in time, you know, depending on how much somebody's willing to buy them for, the price goes up and down. We can trade them on your behalf. Anyway, long story short, that's a significant amount of grants. So the reason that we would do this as a BEC, Better Energy Community Scheme, and not as a one-stop shop is quite simply the cash flow. So in this case, the project, if it was starting today, they would be putting in floor insulation, then they'd be putting in heating. And because it's, we call it, if it was a one-stop shop, the one-stop shop contractor should be either doing the work or paying somebody to do the work for them, so a subcontractor. So in this case, of course, there's a building contractor involved because they're gutting the house and they're building essentially a new house onto the back of it. So that building contractor would now be doing some of the work for us, the one-stop shop, and then he would at the same time have a contract with the customer. So the builder would have a contract with us, would have a contract with the customer, and we would have a contract with the customer as well. So there would be 3 separate contracts, and of course this gets very clunky. As well as that, you know, this project is going on for maybe 10, maybe 12 months. And in this case, we are paying out money day one, and we can't go looking for the grants until the project is finished. So in this case, we tell the customer, listen, we can't see this going through a one-stop shop. We're not a bank, as much as everybody would like us to be, or, you know, we might even like to be ourselves, but, you know, with the amount of or volume of projects we have on, we can't fund projects like this for 12 months. So normally in a case like this, the customer goes off, they get their mortgage, and at the end of it, when it's all done, they come back to us. We might have done bits of it along the way. We might have done, say, the heating, we might have done the heat pump, we might have done the solar or the ventilation, whatever it is. But at the end of the day, the customer will pay us as we go, the same as they would pay any contractor. When it's all finished, we collate all of our paperwork, including insulate, the various types of insulation, the windows, the doors. They all have to hit the requisite U values as we would have stipulated at the get-go. And all of that would be put together, and we would apply then to SAI for the payment. And in this case, you're looking at 36,350 at a later date. Typically once or twice a year, we would sell the energy credits. So either way, that money comes in after the fact, as opposed to along the way, right? So that's the key difference between the one-stop shop and the BEC. The one-stop shop, Ashgrove or an equivalent, it's their problem to deal with the cash flow. As a BEC, all of the same grants are still available. All of the bonus payments, all of the project management payments, the energy credits, it's just as lucrative, but the customer has to pay as they go. Which is a bit of a pain in the ass for some people. However, you are not limited by having to deal with a one-stop shop to go building your house, where in reality, you know, the local builder can do can do as good, if not a better job. Like Ashgrove is not a building contractor. Ashgrove are, you know, heating guys who, you know, 25 years or 23 years of heating, and 5 years of subcontracting attic insulation, pumping wall cavities, and windows and doors. But so one-stop shop is great in certain places. The BEC is probably more beneficial in, I would say, 80 to 90% of the projects that we're seeing. So eligibility criteria. So for the one-stop shop or the BEC, we spoke about it briefly at the start. Keeping an eye on questions. That's the mostly covered, I think. Yeah, I do. And I keep an eye on time. Okay, we're going okay. So the one-stop shop or the BEC, the eligibility criteria. So the houses have to be before 2011. The current BER has to be below C2. Strictly speaking, Shane is lying there. But we have to show that the house makes 100 kilowatt hour of a jump. And if it's above, if it's at a C2 or above, it's very hard to make a good house substantially better. So if it's above C2 to start with, you're unlikely to fit the criteria for a one-stop shop or a BEC. You have to get above a BE2 when you're finished. After you're finished. The measures must reduce energy consumption by 100 kilowatt hours per square meter per annum. Left out the square meters there for some reason. But again, that's to demonstrate that the house has taken a substantial jump by doing the works. Another thing that we have to do is a thing called an SR50. An SR50 is a thing, it's a bit of a pain in the neck for somebody like Ashgrove, but we believe it's a good thing to do. The customer isn't aware of it, but it's evidence that we need to give SAI. It's also good, of course, for the customer that the house is, number one, the house is suitable for a heat pump, and number two, that the radiators are suitable to operate connected to a heat pump. So if you have a really, really poorly insulated house, maybe a heat pump is the wrong solution. So in this case, with an SR50, we wouldn't be able to get a grant if the house was not suitable. So that's a good thing for the customer to know. Number two, when we look at any room, say a kitchen, and we calculate the heat loss from the kitchen, it might be, for argument's sake, say 1 kilowatt. We then, and that would be when the works are done. So we're either pumping the cavities or we're doing the wall internally or externally, and we're doing a ceiling. And so it was previously 2 kilowatts. We've insulated, now it's 1 kilowatt. But the radiator that was there, that was pre-existing, is, I'm going to say, 1 meter long. Well, at the time it was operating maybe at 70 degrees because it was connected to a gas boiler, but now it's going to be connected to a heat pump, which we want to operate at 45 degrees. So will I, running it at 45 degrees, get 1 kilowatt out of the radiator? Yes or no? And if the answer is no, we cannot sign off on this SR50. Now, what this means for the customer is if that radiator is too small, in order to heat your house, you'll either have to run the heat pump for longer hours or run it at a higher temperature. And this, of course, both of those things impact the running cost. And so we often hear about this, people who don't do these SR50s or don't do them correctly, you end up with the running cost too high. So I'm sure everybody will have come across a situation like this. It's quite common. There's no excuse for it. It's a relatively straightforward calculation. It requires us to have the U values of the walls, the floors, the attics, the U value of the windows and doors, etc., as well as a few other bits and pieces. But so it's an hour or two's work for us, but of course we're doing them all day, every day. So I guess it's relatively quick for somebody like Ashgrove. Once we've done those calculations, or once we've done a BER and a technical assessment. Technical assessment is very important when you're doing a heat pump, especially if you're trying to get a grant for it. Again, we have to provide this evidence to SAI that the HLI, which is a heat loss indicator, is below 2 watts. Again, the unit has gone missing there. It's 2 watts per square meter per degree Kelvin. You don't need to know that. That's our job. But again, it provides evidence that the house is suitable. If the house is slightly less suitable, so if the HLI is between 2.3 and 2, I don't know why it's written backwards there, I need to change it every week. So if it's above 2 watts and under 2.3 watts, there are various things which kick in here. What we're essentially saying is to SAI, the house is not exactly in the sweet spot that you want it to be, where you would give the grant for the heat pump, but it's not drastically or massively outside of the 2 watts. So, but between 2 and 2.3 watts, they start asking extra questions. How airtight is the house? Can you provide evidence that the windows are not too bad, that the walls are not too bad? And then these other, what they call backstops, kick in. So they'll ask the individual fabric element backstops. Don't worry about it. It's a piece of work that we have to look after, but as you can see, it's another hoop that has to be jumped through. The grants may not be drawn twice. It says there, it's not strictly speaking totally true. In some cases, an attic grant can be drawn twice. If you drew an attic grant 10 years ago and the specification at the time was maybe 6 inches of attic insulation, well, today the specification is 12 inches, so they will allow you to get the grant a second time to bring it from the 6 up to the 12 inches. There are other similar instances. We won't discuss them now. So in this case, if you need to do a BER and a technical assessment. So when we're showing the government or SAI that we've made a substantial jump from the before to the after situation, we need a piece of paper which has somebody's signature on it, and that's a BER assessor. BER assessor being an individual third party will say, this was the house when we started, so this is what we call a pre-works BER and technical assessment, and later on when the house is finished we'll have a post-works BER. These are 2 signatures attached to 2 pieces, 2 certificates to say we were bad to start with, we're good to finish with, we're showing the other things that we discussed there, the HLI, the SR50s, the 100 kilowatt hours uplift, and the B2 and all of those things. You don't need to worry about them. It's for us to worry about. All you need to know is that there are quite a number of these criteria that we need to hit. That's our problem, not yours. So how would you go about it? In this case, you would get a BER done day 1. A technical assessment should be included if you're going installing a heat pump. I think in this day and age, everybody is doing that. You would agree a contract then between the homeowner and Ashgrove, or whoever the Ashgrove is, the contract would include the works being carried out, say attic insulation, wall insulation, heat pump, solar, whatever it is. It would describe, it would contain pricing, deadlines, any fees or energy credits or waivers. In some of the cases there are waivers where Ashgrove are essentially providing evidence that we have made the customer aware that if we are making your house airtight by insulating your walls and so on, that you might be actually causing an air quality issue. In some of the cases, we definitely cannot do that. In cases like a utility room, maybe, or a bathroom, the customer can actually sign a waiver to say, Ashgrove have made me aware and we are not doing it and we're happy to proceed. Now that might be just because it's an impossible job to get it ventilated because the bathroom is not on an outside wall or something like that. It might just be a huge task. But for all habitable areas, so bedrooms, living rooms, kitchens, etc., ventilation, there's no discussion about it. It's an absolute prerequisite. If you're getting grants, you simply have to do it, no question about it. So once that contract is agreed between the homeowner and Ashgrove, you'd sign the contract. We would then go off and we would apply for the grant before the works commence. In the case of the one-stop shop, provided we're hitting the criteria, we get an immediate green light. That's literally within 1 minute, provided what we're saying is correct. Now, if we're lying, it gets picked up later anyway, but obviously there's nobody doing that. There's no point, you won't get the grants. And in the case of a BEC, it typically takes up, they say it takes up to 6 weeks to get a green light. The reality is because they have far fewer BEC projects than they have a budget for. Anything that hits the criteria gets a green light. So if you can imagine that they had a budget of 100 million for BEC works, right? And if they had 200 million of applications, well, they would pick the best 100 million, right, to get best carbon reductions, etc. When you have 100 million of budget and you have only 60 million of applications or 20 million of applications, they take everything. So we essentially get an immediate green light. Once we get the grant approval, we're allowed to begin works, and then we have to finish it in 12 months. So we're mindful here always that if somebody thinks for whatever reason that they're going to be potentially 12 months or over, we apply for the grant really, really late as possible, and we just make sure that the project, when it's finished, will come inside the 12 months. Okay, so we just have to box a bit cleverly there. So I'm going to skip that. Again, it's only a little image of what we already just looked at. Information gathering, the first thing we do, give you an initial report. More often than not, we can do that without visiting the house, and the reason we can do that is, we can see the house from Google Earth. We know what the BER is in many cases, and because the grants are often kind of 60 or 70%, we can give a person a provisional report without going out. There's two reasons for that. Number one, people don't want to pay for a provisional report. And number two, there's a long wait time for it. So we give them a general quote. And in the case of that project there, we looked at Cairn Woods. We were able to tell those people that it would be 8 or 9 grand to do the works. And, it ended up coming in at 8, 1, 6 or whatever it was. And people are happy enough with that. They're getting 20,000 of grants. So whether it's up or down 1,000 kind of is not so important. Now, there are projects on the far side where it's very important, and we know those by looking at them as well or talking to you on the phone. Once we generate a proposal, you can review it. At this point, people will typically start adding in solar or maybe electric vehicle chargers or doing stuff like this. The proposal starts getting firmed up and refined. Contract is agreed. It then goes to detailed design. That goes to our design team. They make sure that everything is ticking all the boxes, that we've no banana skins when we get to the end, that we're hitting all the various criteria. And once the works are scheduled and installed, and then of course there's a handover period to the customer, maybe a snagging period if it's required, and then you're into kind of after sales. So we have an independent division inside Nashgrove which looks after sales. You have 3 sides: making sure you're operating stuff properly and that you're trained up and all the rest of it. Number 2, that you're scheduling it properly over the next servicing it properly over the next 20 years. And number 3, that if on the day you have a breakdown, or if you do have a breakdown, that you're phoning the same number, and we're making sure you get back up and running as quickly as possible. In some cases, we can do that over the phone, and then we can get a service engineer to you within, as soon as possible. So, so the information days, it's actually on calendar now, but you're already on these webinars, and we do seminars as well. So I'm just going to skip on briefly onto solar panels here and give you a brief introduction. I have a few questions on it there. So I'll give you the dying tour, the Americans would say. So the solar panel, without going into too much detail, will convert photons of solar energy to direct current. We spoke about it at the start of the presentation. So coming off the roof here, or typically it doesn't run down the outside of the wall, it typically runs straight into the attic. They're producing direct current. 2 seconds, drink. So produce direct current. In this case, we have 2 little arrays of solar. For us to make that usable, it has to pass through what we call an inverter. And that inverter then converts it to AC electricity, so alternating current. So this is what we get out of our sockets. It's what runs our televisions, our heat pumps, our tumble dryer, our whatever. If we had a battery, we would be storing the energy before that inverter, because obviously maybe not so obviously, but batteries will store energy as direct current. And then as the battery discharged this energy, whether it was to pump energy or power into the house, into your fuse board here, which is going to your fridge, your cooker, your television, lights, etc., or whether it was going out in the situation or in the case where you had a surplus of it and you were putting it out onto the grid. That little electricity box or that meter box in this case measures how much is being put out onto the grid, and you later on get credit for it. So I'm going to jump into a tiny bit more detail on that. Is there anything there I should have described to you? Inverter. Oh yeah, sorry. The inverter, if you're looking at solar at the moment, you'll be after hearing two terms. One of them is a string inverter, the other one is a hybrid inverter. The difference is the string inverter is the simpler of the two, and it's not suitable for operation with a battery. A hybrid inverter is what you need if you do have a battery, or if you're considering at a later date putting in a battery. Right. By the way, what's not shown here is an electric vehicle car charger. Quite often goes hand in hand with an installation like this. The reason is when you already have an electrician on site, to get him to do an extra hour or 2 hours work, the electric car charger is often, it makes sense to do it at this point. And you can get the grant to do it whether you have the EV or not. So skipping on. So how do we go about sizing it or designing it? So the first thing we would do is we would get your air code. When we get your air code, we can go onto Google Earth. We can see exactly where the house is. We can see the shape of it. And from that, we take that exact location out of Google Earth and it gets pulled straight into our software called Open Solar. Now, we don't always do this for every house because there's quite a big wait list for this stuff. And for most houses, it's not necessary. Some people do want it, and I'll show you here what it does. So we would have, in this case, this is a house where we installed a heat pump about 13 or 14 years ago. So we would have a lot of information about the running costs or energy consumption over the last, 13, 14 years, whatever it is. And what we can see here is that in January, because he has heat pumps, he has electric cars, 2 electric cars in this case, ventilation system. He has, they work from home, both parents work from home, and it's quite a large house to start with. So, and obviously there's more lights and stuff on in January than there would be in June or July. There's probably more cooking in January, February than there would be in July, etc. So, so we can see here January, February high, March is high, April is high, and they're starting to drop, and then it'll climb again later on in the year. The solar really is the opposite. And some people have an emotional response to this and they say, but you're saying, that's no use if my highest months, my solar isn't working. Well, there should be no surprise in that. Obviously, if you were trying to get, as we hear people saying, if you're trying to get a suntan, you wouldn't be surprised in January or December if you sat outside in Ireland, but what we are trying to achieve is over the year, we are trying to achieve roughly 50% of your energy consumption. So whether that's in January or in December or June or July, it doesn't really matter. Some people want it to be in December and January. There's nothing we can do about that. That's just, astrophysics. So from this, we have your energy consumption. We also have what we expect the solar to produce. So this will be dependent on the number of panels. So if you put up 2 panels, it'll do X. If you put up 22 panels, it'll do Y. Of course, it depends on how they orientate. We would ideally like to see them facing south. If they're facing east or west from there a little bit, it's not detrimental. It'll drop off by 3 or 5%. If it's facing like this project is here, directly east and west, it'll drop off by probably 15%. That can be offset by putting up more panels. The software will tell us here when we look at the picture of the house that the south facing bit of the roof is kind of a bright yellow, which indicates that this is what's experiencing the greatest amount of annual solar irradiance, whereas the north side or the east-west side here of the front bit jutting out is getting less. And you can see here that there's a chimney which is causing some shading certainly over a 12-month period. So, by the way, if we were using solar behind this chimney, we would have to use a little device which is called an optimizer. And that optimizer means that, if I did have a panel which was shaded, the others still operate, whereas without the optimizer, if one of them wasn't working or if it was reduced in its output, it actually pulls the others down as well. So we won't cover it in any more detail than that. How do these things get attached to the roof? So, there are different ways of doing that. Just mindful of time, guys, and I think I'm dealing with the questions. I am. So, this is your typical installation method here, where you would take often with a slate or a tile. Tile, obviously, is very simple by comparison. And you cut a little groove here and you screw on your little bracket. That bracket then gets weathered like we see here. There's no way of water getting up underneath that after there's a kind of a dense sponge that gets pushed up there, which is totally watertight. Onto that bracket that you see here, you have these rails. These are aluminium rails, anodized aluminium, which is corrosion resistant. And onto that rail, you can see here, that's the first thing that gets done. These rails get fitted. And once those rails are done, then the solar panel gets dropped onto it and fixed with these little, what they call mid clamps. They just clamp it down onto the rail. So there are other ways of doing it. In some scenarios, we will drill straight through the tile or a slate if it doesn't break, and we will screw straight through it. And we can only do that if you can see this little flashing that we're looking at. It's a little aluminium flashing. That gets stuck all the way up underneath the tiles above it. And you can see here that if any water dripped between these two tiles, it would be down onto this flashing. It would run off. And at this point, there's no welder on the bottom. That is a formed or little pushed shaped piece of aluminium, and the water would actually have to back up by about 1 centimeter before it would hit the first potential entry point, which is, in this case, it's EPDM. It's a very robust, long-lasting rubber. But I mean, there's no way of water backing up on a roof that's at 35 degrees. So water getting up to that is not a concern. So, guys, that's how we fit it. You can see other pictures of it there, but it's the same thing. I'll show you some of the sizes. So each panel is typically, now some of them are slightly bigger, some are slightly smaller. In this case, it's showing 1763. So I'm about 1850, so roughly 6 feet. Whereas in this case, it's about 5'8", and it's about 3 feet across. The inverter here is about 2 foot high by about 1.5 feet across and about 8 inches deep. And I think we're at the end of it there, guys. What I would say to you is I'm going to finish up. I had a few other slides, but being honest, I think we've both covered. And if I go into the next section there, it's going to take me a while. I typically don't cover it in this presentation anyway. What I would say is that on the second Saturday of every month, we do a face-to-face seminar. We typically do that in Mallow, in the GAA complex. It's a longer version of what we've just covered here. We go into far more detail, and it's obviously far more interactive. But it starts typically at 11:30, finishes probably around 1:30 or something like that, maybe 2 o'clock. So that's it. It's the second Saturday of every month. Feel free to come along. If you want more information on solar, we do them every second Wednesday at lunchtime. Again, contact our website, ashgrove.ie, or go on to contact somebody at our office to sign up for it. We typically record these as well, so we can send them to you. Anyway, so that's it, guys. I'm going to finish up there. Thank you for joining us. And I hope it's been of use. Best of luck with whatever project you're doing. And feel free to send anybody on to these. We offer them, and we have been for over 10 years doing these. They're free to, I suppose, educate as much as possible. That's it. Again, my name is Shane Murphy, the Sales and Technical Director. And yeah, that's it. Best of luck. Thank you for joining us. Take care.